Hi, welcome to my video on the derivative using the chain rule, and this is introduction number 2, more explanations. This time we're going to look at composite function and the pattern that we're going to use to find the derivative of constant functions. F of x equals x cubed. The g of x equals sine x. So if we look at composite functions, that's the f of the g of x. That means that f, the g of x, is sine x. Again, the g of x, we're putting in the place of x. In f, the g is going in the place of x. So there it is. Now we have, this is the composite function. So that means that we have, that's f, when we put that in here, we have sine x being cubed, which is also another way to write that. So notice the sine went in the f, so there it went in here, and it gave sine x being cubed. So that's also called sine cubed x. So it's the power of sine. Again, one function is the composite of the other. So when we have that, we have these composite functions, we have to use the chain rule, the derivative of the composite. So we have two functions, one is going in the other. So the rule is d dx on this composite function, which we have here. The rule is f prime bracket g of x and g prime x. So what we do the derivative of f and put the g inside, and then the derivative of g. So in terms of this function that we have here, so if we look at dx on this function, which is sine cubed x, or it could be sine of x cubed, like that. The derivative is the derivative of f, which is the sine of x being cubed. So again, I'm putting the 3 out here. So I'm doing the derivative of this function times that's the g of x, and so what happens, we have the derivative of, again, we got the derivative of the f, which is x cubed, but the x is being replaced with sine x. So the derivative of this, because of the power rule, is 3 sine x being squared, and the derivative of sine is cos. So that works out to be 3 sine squared x cos x. So if you think about it, we do the derivative of this function, we have to do the derivative of the power, which is the cube. So the cube becomes a 3 to a square, but the inside is, because of the composite, the sine x is inside. So we have the derivative of this function, and the sine x is inside, and the derivative of what's inside. So it takes a while to get used to. So that becomes 3, it could be, stay like that, you can say cos x times sine squared x, or it could stay like that, or you could take the sine and write it as a power around it and put a 2 here, or leave it like that. But it's a composite function. Because of the composite, it's the, and how I remember the sign, doing the derivative of when you have a chain rule in terms of composite function, you do what's on the outside first and work to the inside. And you'll see me illustrate that more often in future videos. So I want to show you now. Now I reversed it. I did f of x equals x cubed, g of x is sine x, same as right here. But now in this one, I did the f of the g of x. Now I'm going to do the g of the f of x. So there's still a composite function, but they're twisted around. So that means the g of x, the f of x is going into g. So that's right there. So now this x is going, x cubed is going in right here. So that's sine x cubed. I want to show you again. I want to make sure you understand or see what I'm trying to get at. Right here, the sine x is going in the x, place of the x. So it's the sine of x being cubed. So the cube is the power of the sine. But when we reverse it, now we got the x cubed is going in the sine function. So we have the sine of x cubed. So this power of 3 is with the x, not with the sine. Okay, so that means if we're doing the derivative of this, it's the same derivative, but it's g prime of f of x, what's on the inside, times the f derivative of the f of x. So it's the derivative of the g, and the f of x is inside, that we write with the derivative of f. So in this case, what we have d of x on the sine of x cubed is, g is, we have the sine of the x cubed, like that, times the inside, derivative of the inside. So this is the sine, derivative of sine with the x cubed here, because that's the f of x that's on the inside as a composite, times the inside, derivative of the inside. And so the derivative of sine is cos, and there's the x cubed, and the derivative of x cubed is 3x squared. So that becomes 3x squared cos x cubed. And again, I want to compare the two of them. Notice, again, I just move these up, move them up, just sort of patient just for a second here. Line them up for you. And again, notice the difference. The 3 is to the 3 is the power here, so you do the derivative of the power, and sine x is the inside one, so the derivative of sine. And here, sine is the outside one, and x cubed is the inside one. So you do the derivative of sine with x cubed with the derivative of x cubed. So always what's on the inside you do the derivative of when you're doing the chain rule. So you see more of these, more examples that I'm going to do, because a lot of students get confused with using the chain rule. And like all my videos, if you would like them, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com. Just one word to find more information about me, my videos, and the content. The content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.